So just continuing from the previous video because it did get cut off. One thing we just I forgot to mention was the domain and the range. So the domain is pretty much the restrictions that you have, or what are the bounds from the left-hand side to the right-hand side. So let's just imagine that this graph is blown up to a massive proportion. So I'm going to continue drawing this all the way up to, for example, whatever value it was. Now, if there was no bounds on it, what would the value that it could go up to on the x-axis be? That is what the domain is related to. So what is the smallest value that we could get up to? Well, we could get up to minus infinity in this case. And the largest value that we could get for the x-axis is actually infinity as well. Okay, we're just going to look at simple cases for now where there is, in fact, no restrictions or no restricted domains. However, with the range, we need to be careful here. So the range is the possible values for the Y-intercept. So what are the bounds from bottom to top, or from top to bottom? In this case, what's the smallest value that this graph could equal? So you can see right there that the graph can equal minus 6, so we use a square brackets. But if we keep going up, if we enlarge the scaling of this graph, what are the restrictions going to be? The restrictions are not going to be bound from the top up. So we would say that the range in this case is up into infinity and beyond. Okay, so let's look at the next example that I have. So this is supposed to be example 2, sorry. Let's sketch this using turning point form methods. So the first part says ensure the equation is in turning point form. It's not in turning point form, so what we need to do is get into turning point form. So this becomes y equals minus 3 brackets x squared minus plus x minus 3. And so from here, what we would do is complete the square with whatever's inside. So this becomes y equals minus 3 brackets x squared plus x. Well, what's half of x, or what's half of 1? 1 half, and we would square that, and then we go minus 1 half squared, and then we go minus 3. So the next step is y equals minus 3 x squared, I'm going to put square brackets. So square brackets, just to make it look nice and neat, so this becomes x plus a half squared minus a half squared minus 3. And so this becomes y equals minus 3 brackets x plus a half squared minus 1/4 minus 3. And so 3, that's the same as saying 12 on 4. So in turning point form, this equation will be y equals minus 3 brackets x plus a half squared minus 13 on 4. And then just the final step, we need to expand the brackets here. So this becomes y equals minus 3 x plus a half squared plus 39 on 4. So that is our turning point form right there. From here, the next step is, what is the nature of this turning point? So question 2 is asking, what is the nature of this turning point? I'm just going to move this graph down because we're about to run out of space. So the nature of this turning point is that we look at the sign of the value for a, and in this case the sign is negative. So therefore the graph will be a negative graph, and our turning point will be, I'm just going to simplify this, 39 on 4, so 39 goes into 4, 8, 9, 9 times and 3/4. So 9 and 3/4. So the graph will be a negative, and the turning point will be, what we need to do is we need to flip the sign. So this is going to be negative a half plus 9 and 3/4. So I'll put negative half and 9 and 3/4, as you can see, because I've just simplified 39 on 4 to become 9 and 3/4. So the next step is find the y-intercepts. So I'm going to go back to my red. So 3, to find the y-intercepts, we let x equals 0. So what's our original equation again? Our original equation is y equals minus 3 brackets x plus a half squared plus 9 and 3/4. So we substitute x equals 0 into there. I'm going to move this down again. So what we end up getting is y equals minus 3, 0 plus a half squared plus 9 and 3/4. What we end up getting from here is minus 3 times 1 over 4. After I square 1/2, 1/2 is just 1 squared. 2 squared is 4, so 1 over 4, plus 9 and 3/4. And what we end up getting with this is that we get 3 over 4 plus 9 and 3/4. And you can see with this particular equation, it simplifies nicely so that y is equal to 9. So therefore, y-intercept is equal to 0, 9. So I'm just going to go up just so you can see the working here. So that's quite a bit of working to get into turning point form. So it's preferred that you only use this method if it's already in turning point form. However, it is sometimes necessary or sometimes asked of you to do this. So the next step is find the x-intercepts. So let's find the x-intercepts because we've already found the y-intercepts. So to find the x-intercepts, so question 4, find x-intercepts, and to find the x-intercepts we let y equals 0. So let y equals 0. So the original question was y equals minus 3x plus a half squared plus 9 and 3/4. Just going to check that that's right. Yep. So from here, what we do is, I'm just going to change color because it seems like it's been red the whole time. Let y equal 0, so we get 0 equals minus 3x plus a half squared plus 9 and 3/4. What I'm going to do is I'm going to move the 9 and 3/4 by minusing it over to the other side, so I get minus 9 and 3/4 is equal to minus 3 brackets x plus a half squared. Now I'm going to divide both sides by minus 3. So this side is going to be divided by minus 3. And if I divide by minus 3, I get 3 and 1/4 is equal to x plus half squared. Now just taking a side note from here, because I feel like some of you may have got lost. So 9 divided 9 and 3/4 divided by 3. What we can do is we can simplify this, so this becomes 9. This becomes minus 27. Sorry, not minus 27. 36, 39, so minus 39 on 3 divided by minus 3. We can get rid of the negatives. So this becomes 39 divided by 3 times 1 over 3, which is the same as saying 13 and 3, 13 and over 3, sorry, 13 over 3, which means that 3 goes into 13 four times and 1 quarter. Sorry, I do apologize for this one. That's why I got this one wrong, because this is supposed to be over 4. It's over 4, so this becomes 13 over 4. And so 4 goes into 13 3 times, and remainder 1 over the original 1/4. So from here, we're nearly finished. Take the square root of both sides, so this becomes a square root. 3 and 1/4 is equal to x plus a half, but don't forget you need to take the plus and minus component whenever you take a square root. From here, we minus the half, so this becomes plus minus 3 and 1/4, 1/4 minus 1/2 equals x. Or we could write this as minus 1/2 plus root 3 and 1/4, and minus 1/2 minus root 3 and 1/4. So 1/4, 1 over 9, 1 over 3, 1 over 4, sorry, 3 and 1/4. So from here, we're not done yet, because we need to find what these actually are numerically. So we need to put this value into the calculator and find out what we get, and then this value into the calculator and then find out what we get. So I'm just going to put these in the form now. So brackets, brackets, this will be 0 because y equals 0, and this one will be whatever answer we get here, and I'll put 0 there. So I'm just going to put these into the calculator and work out the value. So after we type this into the calculator, we get approximately these two values. So I know I've done a little shocking thing here, but this is actually related to that value, and this is related to this value. So if we plot these onto the graph, let's plot these approximately where they are. So the first one is where is 1.303? So 1.303 roughly lies around here. Now minus 2.303 lies roughly around here. Now let's look at the other points that we have. So the other points that we were concerned about was the y-intercept of 0, 9. So let's plot that to 0, 9. Sorry, yep, 0, 9 goes up here somewhere. I know it's off the scale. And the last one is the turning point of minus a half and 9 3/4. So minus a half, so it goes roughly around here, and 9 3/4. So I know it's off the scale, but you get the gist of what's going on. So from here, we plot the points and join the line to make a parabola. Okay. And lastly, what would the domain and range be? So the domain, if we enlarge this, obviously these lines aren't parallel, but if we enlarge this to the point that it's really large, what we get is the domains from negative infinity to infinity, and the range, well, it can go from minus infinity, because it can go all the way from down to the very bottom, up until 9 3/4. So hopefully that ties off sketching with turning point form.